Hello friends, welcome to Circuit Data, and today we are going to learn how to interface and soil moisture sensor with an Arduino board. So before moving into the content, if you like our Arduino tutorials, so do subscribe our channel, and if you want to know more about the Arduino and other technologies and prototyping. So before let us move into the content. So before, as usual, before moving into any of the interfacing part, we have to know about the sensor, right? So how the sensor is going to work, what is going to happen. We have to learn everything, right? So let us see what the soil moisture sensor is going to do, how it is going to work, right? So you can see on the screen, right? Soil moisture sensor, but here you are having two components, right? So this is our main sensor. Okay, this is our main sensor, and then you can see here this is our module, or this is the interfacing module, right? You can call it as an interfacing module. So now let us see what the sensor, how the sensor is going to work and how the interfacing module is going to work, right? So if you move into the sensor, so you can see this is having some probe like structures, right? So these are the probes, and we are going to dip this complete probe. This is the soil moisture probe. This probe will be dipped in the water, right? Whenever this probe is dipped in the water, then what happens here is the resistance of this probe. Okay, so the resistance of this probe will get reduced if the soil in which we are dipping this is having more moisture, and the resistance will increase if the soil in which we are dipping it having less moisture, right? So depending upon the resistance value, we are going to sense whether the soil is wet or whether the soil is dry. Okay, so how it is working, whenever we are placing this probe in a soil, okay, the soil for which we want to measure the moisture, if the soil is having the moisture, right, then what happens, the resistance of the probe will get reduced. Okay, and if the soil is having very dry condition, if the soil is not watered for a long time, and because of that if the soil is dry, then what happens, the resistance will get increased, right? So only thing is, depending upon the resistance, right, depending upon the resistance, we are going to measure whether the soil is wet or whether the soil is dry or the soil is perfect, right? So it is very clear. Again, I am explaining you, just repeating that if the soil is very wet, then the resistance will be very low. So if the resistance is very low, then we are going to detect that this is a wet soil. Okay, and if the soil is dry, then the resistance will be very high. So if the resistance is very high, then it will be representing that the soil is dry. And if the soil is perfect, that is neither the resistance will be very low or the resistance will be very high, then we can call it as a soil is a perfect soil, right? So the everything, whatever the thing is going to do, everything will be performed by this probe here, right? So and then now if you are moving to the next part, that is what is the use of the interfacing module here, right? So here the interfacing module, what it is going to do is, whatever the resistance value that it is getting from the probe, it will take the value and it will send this value to the Arduino board, or for whatever the controller to which you are interfacing the module, it is going to send that, right? So and what is the specialty of this interfacing module is, so this module will can operate for a voltage range of 3.3 to 5 volts. So you can give a 3.3 volt supply, or you can also give a supply of 5 volts, right? So this is how the soil moisture sensor is going to work. So the main thing, whatever the main thing that is going to happen here, so it will be performed by the this probe. Okay, whatever the main thing happening here, so all the main thing will be performed by this probe, and then whatever the resistance that this probe is measuring, so that resistance value will be communicated to this to this module, and this module here you can see this is one of the comparator and this is one of the this potentiometer. So this potentiometer can be used for calibrating, and this comparator can be used for comparing the values, and then it will give the output here. So you can, what the specialty of this module is, you can take an analog output or you can take an digital output. Okay, it depends upon you. If you want a digital output, then you can take the digital output, and if your application need the analog output, then you can also take the analog output. So you are having both the digital and analog pins. It depends upon you. If you want the digital, if you want the analogs, then you can take anything. And the supply is also very comfortable. So if you're having only 3.3 volt supply, then also the module will work perfectly. And if you are having 5 volt supply, then also the module is going to work very perfectly, right? So the pin diagram also here very simple. The thing I have here, you are having a VCC pin, here you are having a ground, and then the digital and analog. So you have to give the VCC and ground for getting the power supply to the complete module, and also for the probe. Okay, and then among these analog and digital pins, so if you need the digital output, then you will use the digital pin, and if you need the analog output, then you will use the analog pin, right? So this is how we are going to do this. Okay, so it is very simple, right? So now let us move to the connection of this particular module, right? So first of all, I will try. We are going to do this in a two parts, right? I will make you learn how to use the digital pin and how to use the analog pin, right? So the connection that I am showing here. So this particular connection that I am showing here, this is for analog. That means I am collecting the data from the analog pin of the module, right? So it's very simple. So you know that we are having a ground here, right? So we have to connect the ground, that means this black one, to the ground of the Arduino. But I have changed something here. So what the thing that I have changed here? So you can see here this particular VCC, right? So I had not connected the VCC to the 5 volts or the 5 volts pin of the Arduino, or to the 3 volts pin of the Arduino. So what is the reason for that? But instead of that, what I had done here, so you can see here, the crazy thing that I had done here is I had connected this VCC to the 7th pin of the Arduino, and which is not a power supply pin, but it is a digital pin, right? So why I had done like that? The reason for doing like that is, you know that this particular sensor is used for measuring the moisture, right? It is used for measuring the moisture content in the soil, right? So that means the sensor will be complete, that means it will be in a contact with the soil for a long time, right? So whenever the sensor is in contact with the soil for the long time, and if the soil is having the moisture, and you know that we need to give the power supply to this probe, right? This probe will be in the soil for continuously, it will be in the soil, and if you give the power supply continuously to this, then what happens, because of the moisture in the soil and because of the current flowing in that, what will happen, the corrosion will get happen here, and because of the corrosion, this particular sensor will get corrupted very quickly. Okay, so we have to again exchange it with a new one. Okay, so because of that, what we are going to do is, instead of giving, if you are going to connect the VCC of the module directly to the 5 volts or 3.3 volts, then what happens, if your Arduino board is on for a whole for 365 days of the year, okay, then for the 365 days of the year, the current will get flowed in the probe, and because of that, the probe will get damaged because of corrosion formation here, right? So because of rusting, we see, call it in a simple words, because of rusting, right? So instead of that, if we are giving the supply from any one of the digital pin, okay, so you know that if I am giving the digital pin as the high, okay, if I give the high on a digital pin, then the digital pin will give a 5 volt supply here, right? So what I will do, whenever I need to measure the soil moisture, because for example, I need to measure the soil moisture at the morning, and again I need to measure the soil moisture at the evening, and then again at the night, okay, for example, right? So what I will do, when I am measuring at the morning, then only I will give the high on this pin. So whenever I give the high on this pin, then the sensor will get power, and the probe will get the power, and then the probe will give the moisture value here, okay. And once I get the moisture value, then again what I will do, I will make the pin as low, so the probe will not get any current here. So whenever we have a use, then only we are giving high on the 7th pin, and then only the probe is getting the supply. And whenever we don't need to measure, then we are going to give low on the pin, then the probe is will be in the off position, so no current will be getting flowed here, and because of that, the corrosion will not happen quickly, and the life of your sensor will get increased. Okay, so only that, because only when there is requirement, then only I am going to do that. Okay, so this is the interfacing part. So only thing is, instead of using the VCC directly to 5 or 3 volts, I am giving it to an any of the digital pin and making it high when I need to measure, and making it low when I no need to measure, so that the probe will be in on or off condition. Okay, and in this one, as I said to you, we are using the analog pin. So what I am doing, I am connecting the A0 will represent the analog and D0 will represent the digital. Okay, so I am connecting the A0 to any of the analog pin. You can connect it to any of the 6 analog pins, but I am connecting it to A0. It is not compulsory. You can also connect it to A5, A3, whatever you want. Okay, so this is how we are connecting the connection here. If you want to use the analog pin, right? If you want to use the digital pin, then nothing is going to change here. Everything is similar. Like here, the ground will be connected to ground of the Arduino, and the VCC will connected to any one of the digital pin. That means here it is 6, 7, sorry. And then what I am doing, instead of using analog pin, I am using the digital pin. I am connecting the digital pin to any of the digital pin. So here I use the 8th pin, right? And then I am getting the data on my digital pin. Okay, in the previous one, we are using the analog pin of the sensor and getting the data on an analog pin of my Arduino. Here I am using the digital pin of the sensor and getting the data on a digital, right? So now let us move into the coding part. Okay, if you come into the coding part, so for using the soil moisture sensor, you don't need any of the library, right? Without the library, you can use the soil moisture sensor. Okay, so what I am doing here, as I explained you, that I am not connecting the power supply of that means the VCC pin of my sensor with the 5 volts or 3.3 volts, because I am just switching on when I need the data and I am switching off when I don't need the data. So any of my digital pin. So I am using the 7th pin as my sensor power. So I had defined the 7th pin. That means I had given a name to my 7th pin as a sensor power. Whenever I say define, that means I am giving a name to one of my pin, right? And then I am giving the A0, because I am going to do the analog pin collection. Okay, I am doing the analog data collection. So I are using my A0. That means I am connecting my sensors analog pin to the A0 of my Arduino, right? So I am naming my A0 as a sensor pin. Okay, and then coming on to the voice setup. Initially, when the Arduino starts, okay, so this code is going to work, right? Initially, when the Arduino starts, the first thing that we have to explain to the Arduino, that the sensor pin, the sensor power pin, that means the 7th pin, should act as an output. That means it has to give the data out, because it is acting as a power pin, then you should definitely have to give the data out, then only it is going to act a power pin, right? And then I am also making the Arduino to know that whenever you are switching on, don't make the sensor pin high, just make the sensor pin low. Okay, that means whenever the Arduino switches on, it will not going to give any data to the sensor. Okay, so when I want to measure the value, then only I am going to make it high, and remaining time it will be low itself. Okay, so the two not allow the power to the probe, and to save the probe from the rusting, and to increase the life of the probe here. Okay, and then I am mentioning the baud rate. I am using the normal default baud rate, that means 9600. Okay, you can increase the baud rate. Don't think that every time I am using 9600, you can increase the baud rate. Whenever you increase the baud rate, you have to select that particular baud rate in your serial monitor, right? And coming on to the while loop here. So first what I will do, I will print a line that my analog output is. Okay, so what I am doing here is, initially I am testing my module. Okay, I am just testing the module, because if I want to decide that decide that the sensor have to view that the moisture is perfect, the moisture is low, or the condition is wet or condition is dry, I should know the threshold value. That means if the value that I am getting from the sensor is above a particular value, that means the moisture is dry. If the value that I am getting from the sensor is below a particular value, then that is the moisture is wet. That means the soil is wet. And if I am getting the value around the threshold value, that means the soil is perfect. So I have to have that value. Okay, that value, depending upon that value, if I am getting the sensor data above that value, the soil is dry. If they are getting the data from the sensor below that value, the soil is wet. and if I am getting the value around the threshold value, and that then the can say that the soil is perfect. So first I need to know what is the threshold value. Okay, fine. So first I am doing a test code here. So what am I explaining you on the screen? This is our test code, right? So I am just test code. What we are going to do? We are going to dip the sensor in a wet soil, and we are going to keep the sensor in the dry condition. So in the wet condition, we are going to see what are the values that I am getting from the sensor, and in the dry condition, we are going to see what are the values that you are going to get from the sensor. And depending upon that, we are going to decide the threshold value, so that if it is greater than that, then it will print that the soil is wet, or the soil is dry, or the soil is perfect. So we need a value. Okay, so in this code we are trying for that value. Okay, so I am just printing the line analog output, and I am getting the read sensor. Whatever the data that I am getting, I am going to read it, right? So this is a function here. So what is going to happen inside this function? That will be here. Okay, you can see here again I had written another loop. In this loop, what will happen? First, the what that means here, just I have printed that whatever the read sensor value, that has to be displayed on my serial monitor. But what is happening in the read sensor? Neither I had used any library. If I have used any library, then I can say that the read sensor is in the library. So whatever the code behind the read sensor, that is happening in the library, and I am getting the value on the serial monitor. But I had not used the library here. Then what is happening behind? So if I had defined any function like this, then the background code can be written like this: read sensor, like whatever, like while loop, and open and close brackets. Like similarly, read sensor, open and close brackets, and in between this we are going to write our code. So what will happen whenever the read sensor means, first the sensor pin, power pin will be high. That means whenever the this seventh pin will be high, my sensor is going to get the power. So once the sensor gets the power, we are going to give it a 10 milliseconds of delay to allow the power to settle down in the sensor properly. Okay, after that, what I am going to do, I am giving my sensor to read the analog data, because we are using the A0 pin of our sensor, right? The data that we are getting, it will be on A0 pin. So whatever the data we are getting on analog pin, that data is analog data, right? So for reading the analog data from analog pin, we have to use analog read, right? So and whenever we are using the analog read, so the data that we are getting on the A0 pin from the sensor will be read. Okay, and then once we read the data again, we are making the sensor pin low, because we have making it high. That means we are powering the sensor to read the data. We have written the data. Again, we are powering down the data, right? So this will happen continuously like that. Okay. So this is the test code. So what I am going to do, I am going to connect my Arduino. Okay. Before connecting my Arduino, let me show you the connection here. This is my Arduino board, and this is the interfacing module, and this is my soil moisture sensor, right? And here I am using some water here. Okay, because I am not having the soil right now. Okay, so I am using a water. If I place the sensor in the water, it will be like wet condition, and if I place the sensor out from the water, it will be the dry condition. Okay, so the connection is same. You can see here I have connected the seventh pin. This seventh pin is acting as a power pin. So when I need to give the power to this probe, I am making it high, otherwise low. And then we are using the A0 pin here, right? And then we are using the A0 pin here. This is our seventh pin, this is our A0 pin, and this is our ground pin. Okay, so now let us test the code here. Okay, so what I will do first, I will upload the code into my Arduino board. So it has been uploaded, right? Now I am opening my serial monitor. Along with that, I will open the display for you. So now you can see I am getting the values around above the 1000, because it is in dry condition. It is not having any moisture. That's why it is giving the value above 1000, right? If I make it wet, so I have kept it in the water. So now you can see here I am getting the values around 250, 240, around 250, 240, like that, right? So depending upon that, we are going to again when I am removing it out, so it will be the wet condition. Okay, so it will be the wet condition. Again when I am dipping it in the soil, it will be the dry condition. So wet condition when I am dipping in the water, and when I am taking it out, it will be the dry condition. Okay, so that means in the dry condition we are getting a values above 500, and in the wet condition we are getting a values below 250, and between 250 and 500 it will be the perfect condition for the soil, right? So we can decide like that, because it is very clear when we are dipping in the water we are getting below 250, and we are placing out, we are getting above 800, and between that we are going to get the perfect condition, right? So now let us move to the actual part. Okay, so let us move to the actual part. So this is the actual code. Okay, so now I had decided my threshold values, right? If it is threshold values, if it is less than 500, then it is wet, and if it is greater than 700, then it is dry. Whatever the data that I am getting, if it is greater than 700, then it is dry, and it is between 500 to 700, then it will be perfect condition. Okay, so I have taken one threshold as 500 and one threshold as 750. Okay, so I have named the 500 threshold as the soil wet, and I had named the 750 threshold as a soil dry. Okay, again this is the pins. So I had used some of the pin as my power pin and A0 as my sensor data, the pin that from which we are getting the data. And the voice setup is same. We are making the sensor power pin output, and initially we are making the power low because when we need the data, and only we are switching it on. Okay, so and again we are, whatever the data that we are reading from the sensor, it will be stored in a variable known as moisture, right? And after storing the value, that means if it is 750 above or 500 below, whatever the number that we are getting from the sensor, it will be stored in a variable named moisture, right? And then I am printing a line analog output, and then I am printing the value that I am getting from the sensor. Okay, and then here the main thing starts. Okay, here we are determining the threshold values here. Okay, so how we are determining the threshold value? So we are here, it is clear that whatever the data that we are getting from the sensor, that particular data is getting stored in the moisture, right? So we have to compare the data that we are getting from the sensor with our threshold values. And what are our threshold values? One is 500 and other is 750, right? So first, initially I am trying to determine the wet condition. Okay, so for the wet condition I am going to use the if else condition. Whenever you are defining something, we have to use the if this happens then do this, if else do this, else do this, like that. Okay, if this happens do this, else if this happens then do this, otherwise do something else. Okay, so if else condition we are going to use if else and then if else. Okay, so first we are going to compare the moisture, because the moisture is the, if in the bracket we are writing the condition, if the moisture, that means the value that I am getting from the sensor, is less than soil wet. What is the soil wet here? It is 500, right? That means if the sensor value, what the sensor value is stored in the moisture variable and the 500 has been stored in the soil wet. That means if the sensor value is less than 500, then you have to print on the serial monitor that the soil is wet. Okay, if this does not happen, that means if the value that we are having in the moisture is not less than 500, then if the value that is available in the moisture is equal to or greater than soil wet, that means it is equal to 500 or greater than 500, and if the value is less than soil dry, what is the soil dry? That is 750. Then what we have to print? We have to print soil moisture is perfect. So you have to do here, if this happens, then you have to print wet. Else, if the moisture value is equal to 500 or greater than 500, and it should be equal to 500 or greater than 500, and then if it is less than 750, soil dry means in the soil dry we are having the 750 value, right? That means if the first condition is if it is less than 500, then you have to print the soil is wet. Other condition is if it is not less than 500, then it will be greater than 500 or equal to 500, right? It will if it is greater than 500 or it is equal to 500, and if it is less than 700. Okay, if the value is greater than or equal to 500 and it is less than 750, that means if the value is between 500 to 750, then you have to print the soil moisture is perfect. Okay, otherwise if the first condition less than 500 is not satisfied, or the second condition equal to 500 or in between 500 to 750 is also not satisfied, then what you have to print? Then definitely it will be greater than 750, so you have to print the soil is dry, need to water, time to water, right? So this is how we are doing it. Okay, this is how we are writing the conditions. So for writing the conditions we are using if, else, or you can also use, if you are having three conditions, then first if, and then else if, and then else. Okay, again I am explaining you the if else conditions because in our tutorial this is the first time we come across with the else if else conditions, right? So if you are to use the if condition, right? If, and then in the bracket you have to write the condition. What is the condition? Moisture is less than soil wet. That means the sensor data is less than 500. Then in the then you will open the bracket, and you will close the bracket, and between these you are writing that we have to print the soil is wet, because we had decided that if the value is less than 500, the soil should be wet. Okay, so, and if this is not satisfied, but I am having other condition. The other condition is if the value is equal to 500, or it is between 500 to 750, then it should be perfect soil moisture. It is perfect. The soil is perfect, right? So what the other condition that I am using, it is else if the moisture is greater than or equal to the wet soil, that is 500, or if it is less than 750, then you have to print oil is perfect. If the second condition is also not satisfied, then you don't, in the third condition there is no need to write the condition, because the first condition is less than 500, it is satisfied, then print, otherwise it will go to the second condition. And the second condition that we are having here is if the value is equal to 500, or it is between 500 to 750. So if it doesn't satisfy this condition also, below 500 not satisfied, 500 to 750 not satisfied, then the Arduino is that much intelligent that it should know that the other value will be greater than 750. Then there is no need for writing the condition here. You can simply write the else, and you can directly print that, because the soil is dry. Okay, right? This is the this is the way that we are comparing. Okay, the first line represents that moisture is 500, then it will print soil is wet, and if the moisture is between 500 to 750, then it will print soil is perfect. Otherwise, whatever the other data that is, that means greater than 750, it will print soil is dry, time to water. Okay, so this is the code, and remaining all the parts is same as we had explained previously. So now what I am going to do, I will upload this. Okay, so you can see here my code has been uploaded. So now I will open my serial monitor. Okay, so it is showing me the soil is dry, time to water. It is because you can see here I had placed my soil moisture sensor out from the water. So it is my dry condition, right? So now let us see whether it is showing the wet, because now it is a dry condition. That's why my serial monitor is showing that soil is dry, time to water. Okay, if I place this in the water, so now you can see because the water is wet, so it is showing that the soil is too wet. Okay, so that you have to switch off the motor because the soil has become too wet. Okay, so in between them it will be the perfect condition, but the perfect condition is not possible right now because I am not having the soil right now. Okay, so this is how we can use the analog pin. So you can see here I had used the analog pin, and this is how you can use the analog pin of the soil moisture sensor, and you can write the conditions that whether the soil is wet, dry or perfect. Okay, so now let us see how we can write the now let us see how we can use the digital pin also. We can also use the digital pin, right? So for using the digital pin, what you have to do, the first thing that you have to do is here you have to change the pin number, because previously we had used A0 as our sensor pin, but now we are using the 8th pin as our sensor pin, right? So now what I am going to do, I am changing my A0 pin and I am giving it to 8th pin of Arduino, right? Okay, so I am using the 8th pin of my Arduino, and I am using the not A0, but I am using the D0 of my sensor. D0 means the digital pin of my sensor. Okay, so the digital pin of my sensor has been connected to 8 pin. Previously, the analog pin of my sensor has been connected to A0. Okay, and remaining things are same. Whatever the data that you are getting, the remaining code is everything is same. Okay, but the only condition here, what changes here is, okay, what changes here is, you have to remember here is we are using the digital pin, right? So the digital pin is not going to give 500 750, because 500 and 750 all these are our analog data. Okay, so what is going to change here is it will give either high or low. Okay, if the soil is, that means if the soil is wet, then it is going to give the high, and if the soil is dry, then it is going to give low, and depending upon that we have to decide whether it is perfect or it is dry condition. Okay, so the wet condition is not possible with the digital pin. You have to remember that the wet condition is not possible with the digital pin. Okay, because in the wet condition we need two threshold values, but in the digital we can have only either 1 or either 0. Okay, so you can, if it is 1, then you can decide that it is a dry condition, and if it is 0, then you can decide that it is a perfect condition. You are not having a middle value between 0 and 1. It is not possible with the digital pin, right? So now let us see, everything here will be same, but here I am taking the sensor value into a ball lamp. This is not this is also a variable. You can use anything here. Previously we had used the moisture, so you can use the moisture variable here. There is no problem with that. Okay, so I am digital output, and whatever the value that we are getting from the sensor, that is stored in the val, right? We are printing that. Okay, and then the condition is if the val occurs, if there is any value, that means 1, then the soil has to print that the soil is dry, you have to water it. And else, that means if it is not getting 1, then it is going to get the 0, right? If it is getting 0, then you have to print that soil is perfect. Okay, so only 2 conditions here. So previously we are having 3 conditions. I will show you the previous one. In the previous one we are having 3 conditions. Like if it is less than 500, that's why if it is less than 500, soil wet. Else if it is between 500 to 750, then perfect. Otherwise it will be dry. Okay, but in the digital one we are having only 2 conditions. If it is 1, then dry. If it else means other 1 is not, then it is 0. So if here we are using only else if, there is no if else condition. But in the previous analog one we are having if, else if and else condition. But in the digital one we are having only 2. If 1, then it is dry, otherwise it will be 0, then it is perfect. Okay, so now let us do this. Let us check this. First upload the code here. Okay, but what happens with the digital pin is we have to calibrate it, right? When you are using the digital pin, you need to calibrate. So I had uploaded my code. I will show you what the data I am getting on my serial monitor. But before that, I need to calibrate my sensor, right? So what I am going to do is, you can see on the sensor interfacing module, you are having an potentiometer here. So you can take a screwdriver, and what you have to do, this is our status LED. This is our on LED. This is our status LED. What you have to do, you have to rotate this in the clockwise direction. Still the status LED blinks. Okay. You can see here the status LED is blinking now. Okay. Once it is blinked, you again rotate it in clockwise, anti-clockwise direction. So first you have to rotate it in clockwise direction so that the status LED blinks. That means it has taken the value, and what the value that it has taken, it will take the dry condition. So once it taken the value, rotate it back to the anti-clockwise direction. Okay. And then now you can put it in an moisture and check. Okay. So let me show you the serial monitor here. So the serial monitor is showing that the soil is dry because I had calibrated it. So this is for the dry condition. So I am placing it to the head. So it is coming to know that the soil is dry. Okay. When I place it in the water, this is showing that my soil moisture is perfect now. Okay, this is my perfect soil moisture condition. This is my dry condition. So it has been perfectly calibrated now. So you can see when I place it in the water, so it is showing that my soil moisture is perfect. Okay, because it is a wet condition, and I have explained you that this in the digital condition it is going to get only 0 or 1. So you can see here I am getting the 0 value. So it is showing my soil moisture is perfect, and now it is showing that my moisture is right. So I have calibrated it, that's why I am getting this value. So if you are not getting that, place it in the wet water, rotate this, and then calibrate it. Okay, you have to rotate it and you have to calibrate it. Okay, so this is my wet condition, this is my dry condition. But the Arduino, when I place it in the wet condition, it is showing the moisture is perfect, and when I place it in the dry condition, it is showing that my moisture is dry. So this is how you can do this with an digital pin also. Okay, so what we had done today is, first we had tested it, because for doing the analog we have to test it and we have to take the threshold values. And after that, what we had done it in analog condition. We are using the analog pin of the sensor and doing everything, and now we are using the digital pin and we are doing everything, right? So this is how you can interface a soil moisture sensor with an Arduino board. You can try it on your own, and the complete code of this, the 3 codes, that means the testing code for the analog, and then for the analog and for the digital pin. All the 3 codes. Okay, we are having three codes here. The first one is the testing code for the analog pin, and then the analog pin condition. We are using analog pin of the sensor, and then the digital pin condition here. Okay, all the three codes will be available in our website, and the link for that particular tutorial, this particular code will be available in the description. So you can go to the description and you can get the code, all the three codes, the testing code, the analog pin code, and the digital pin code there. Okay, so if you like our content, if you like this video, then don't forget to hit on the like button, and for more exciting content, subscribe our channel. Okay, thank you.